All right, for lesson 4, this is page 3 of lesson 4, where we're going to talk about finding the equation of a line that would be parallel or perpendicular to a given line and graphing. So we found out in the warm-up, for a line to be parallel to another line, as in never running into each other, the slope has to be identical for both lines. All right. For perpendicular, the slope has to be opposite sign and reciprocal. So in other words, if you have an m equals 2 for one line, okay, a positive 2, all right, for a line to be perpendicular to it, it would have to be a negative line, because this is be positive. This would have to be a negative line. So it has to be an opposite sign. And then if this goes up by 2, this has to be exactly perpendicular. So it's going to be a half. This is a 2 or a 1, so reciprocal will be 1 over 2, and opposite sign would be negative. Okay, so you need to put that on a flashcard. You can. And that's just the slope. We did that in the warm-up, but we want to make sure we understand how to write the whole entire equation of the line. So we need to put whatever slope that is in the point slope form. So that means you're going to be using the point slope formula for these as well. All right, so write equation of the line in slope-intercept form that would be parallel to this line. So they're giving you a line that is 2x plus y equals 6. And then they're saying it has to go through this point right here. Okay, what do we need out of the line? Well, we need to know the slope of this line to be able to know what the parallel slope would be. So this is in standard form. You want to turn it around into slope-intercept form by isolating the y. So subtract the 2x, that's on the wrong side. Right, push this b over, it's a positive 6. So the slope for the equation they're giving me is a negative 2. All right, so the slope of the line that would be parallel to it would also be a negative 2, but it would go through this point here that I'm going to label x1 and y1 and put it in the point slope formula. All right, lots of negatives. Don't lose all those negatives. So this is going to turn into y plus 5 equals negative 2x, x plus 4. Then we want to distribute and move the 5 over. So y plus 5 equals negative 2x minus 8 minus 5. So this is going to be y equals negative 2x minus 13. That is the equation of the line that would be parallel to this other point, this other line that would go through that point. Okay, that's the answer to the question. The next one says, for B, it says perpendicular to this equation here. So you can't tell what the slope is of this one, so let's divide by negative 2 properly to get the y alone and find out that this is an equation of a line that has a slope that is negative 2 halves. A line that would be perpendicular to it would have a positive slope and a reciprocal. Okay, so we want a line that has a slope of 2 over 7 that goes through these points here. Oops, let's call that a y1 and x1. So y minus a minus 6 plus the slope that we want, x minus 4. Okay, so this be y plus 6 equals 2 over 7x. Let's distribute. 2 over 7 times 4 over 1 is 8 over 7, and there's a minus there. Okay, and then we want to subtract 6. How do you subtract 6? Oops. How do you subtract 6? Hang on. Oh! Let's fix that so it doesn't get so big again. Okay. Sorry, that was a 2 over 7. Okay, so how do we take a negative 8 over 7 and add a negative 6 to it? Well, what's a negative 6 in terms of 7? That would be times 7, so that'd be a negative 42. That would be a negative 50. So our final answer, which I'm kind of out of room for, would be y equals 2 over 7x minus 50 over 7. And I did check that when I did the key. What you can do is put this ordered pair back in here, put the negative 6 over here, and believe it or not, 2 over 7 times 4 minus 50 over 7 is a negative 6, okay? So that's the equation of the line. Sorry, it's all kind of jammed on here. All right, so those are one of each of those, and then we want to graph an equation. We want to remember how to do this by putting this equation of the line in slope-intercept form. Then we want to plot it on a graph by starting with whatever b is, right? That's step 1 for graphing something on a rectangular coordinate plane here. You got to put the b on here first. And then use the slope from the equation to find another point on the graph. So you go up from the y-intercept or down, and then left or right, and make sure that the slope matches. So for instance, we have this equation right here. Your slope is 3, your y-intercept is 2. Your y-intercept is 2, so the point is 0, 2, right? That's your y-intercept. This is a y, this is an x. That's a y-intercept. So we do that first. That's step 1, okay? And then from this point of 0, 2, you want to use the rise over run for the slope. We said the slope was 3, so that's 3 over 1. So that's the rise, and the 1 is the run. So from B, go up 3 and over 1. That gets you over here to 1, 5. Okay, and if you want to go down 3, 1, 2, 3, and back 1, you get another point, which is negative 1, negative 1. Okay, so you can go down 3 and back, or you can go up 3 and over, and that gets you to the same line. This goes up the mountain, so it's a positive slope, so the slope is in the right direction. Okay, so look at these here. These are not in slope-intercept form, so the first thing to do is move them over. 2y equals 6x minus 4, and then divide by 2 to get the y alone. So this is really y equals 3x minus 2. So that means our y-intercept is a minus 2, right? 0, negative 2. And then we our slope is still positive 3. So 1, 2, 3 up and 1 over puts it there. Notice it's the same tilt as the other. It's just in a different spot. You can go 1, 2, 3 and over to put another dot if you want to. You can go up 3 more and put another dot. These are all solutions to this linear equation. Okay? It's a good practice to put the ordered pairs next to the points. Okay? All right, this problem is in point slope form, so let's turn it into slope-intercept form so we can have our b, okay? I need the b, so let's distribute and move this over. So you get y equals negative 2x minus 1. So our our y-intercept is negative 1. And our slope is down 2 and over 1, or up 2 and back 1. That goes in a negative direction, right? That's a negative slope. This was a positive slope, so make sure you end up going in the right direction. We wanted our m to be negative 2, and that looks right, okay? This one's not in the right form. Get rid of that negative. Excuse me. So y equals x plus 3. Our slope is 1. Our b is a positive 3 again, so that's here. And then up 1 and over 1, or down 1 and back 1. That's just going to hit right there. Any of those points will work. You should be putting at least 2 on there. Doesn't matter which 2. Negative 1, 2, that's that one. That's that one. Okay. Alrighty.